Okay, we're going to take a look at, real quick look at using Casio for regression and for modeling data. So first thing you do is go to Menu and go to Stat. And into Stat you go and you're going to put some data in. Now, I'm going to put some very quick data in here. So these would be our heights and they would go in list 1. And I messed that up. Exit. Clear. 0.4. I'm not going to put much in here. And then over here, you would put your average spatter diameter. And I'm just going to pick some values real quick. Now, once you get this up, you can get your graph, your data to graph, and there we've got a scatter plot. And if I hit calculate, I can then do various regressions where I can get a line of best fit or whatever model I want to use. The X here is my straight line graph, so if I hit F2, I'll get this data here, which is basically telling me what the equation is, tells me what A is, tells me what B is, and the R square, which is what we call correlation, tells us how good a fit it is to the data. 0.9 is quite good. The closer to 1 it is, the better fit it is, and we draw that and it will put a line of best fit in there. Now if I exit out of that, I can do this again and again. I can do this for whatever model. I go to Calc. Now if I want to check a cubic or a quadratic, I can go quadratic, which is x squared. You'll see that I've got an x squared quadratic equation down here. It tells me what A is, tells me what B is, tells me what C is, tells me the R squared value, and I can get it to draw it as well. So that's how you basically get your graph to work on a Casio. Okay, this is just a quick little tutorial to help you with your blood spatter activity. One of the websites that could be quite useful, you can use your graphing calculator for data collection and so on, but Desmos.com is a nice little graphing calculator that you can then copy and paste your graphs and so on into a Word document from by taking a screenshot. So I'm just going to show you very quickly how you can use this for the activity. You can take the data, if you take your data that you have done up, and you put it in an Excel spreadsheet and copy it and go to Desmos, which is a website-based activity, and then you can just paste your data into Desmos very quickly, and it will graph your data for you, and it will show you a graph of the scatter plot. Now, you can change the scale of this by changing your x-axis and your y-axis if you find that the scale is not appropriate, and you can play around with that. Now, if you want, we're going to be modeling and creating both a linear and a quadratic model to see how well we can model this data and then make some predictions around it. So the first kind of model would be a straight line of best fit. So we're going to go y, and we need to tell Desmos what y value we're going to be using. So we use a little subscript called y1. Double click that a little bit, and then you're going to use this little symbol here that is an approximate, which tells your software to do a regression. Now we're just going to go mx, which is a basic with a little subscript on there of 1. We're just going to do the basic general formula for a linear regression, and you're going to see that our graph, our software will graph a straight line through the data. It will give us some values. It will tell us what our gradient is. It will tell us what our y-intercept is. We basically have the equation for this. It'll also give us what's called an R squared value, which you don't need to know a lot about, but this is just telling you how close a fit your model of a straight line to this data is, how good it fits. The closer to 1 your R squared value is, the better the fit. So we can test that out, and you can see that happening. We can also then do a quadratic regression by, again, just using a basic standard form quadratic equation. Make sure that you use the square and then just go plus bx and use your little subscripts to tell it what x you're dealing with, and then plus c. So you can see that it now does a quadratic fit, and you can see the r squared value is given, and again how close it is to 1 helps you decide whether it's going to be a good fit for the data. It tells you what your a is, tells you what your b is, tells you what your c, so you've now got your equation. And you can take a look and see if it makes sense that this is a better fit and make some decisions around your model. So this is a quadratic model, and we also did a linear model.